Hello everyone, Tom from EveryStepPhysics.com, EveryStepCalculus.com. I'm going to do a problem off of a test in physics. And let's do it. The problem reads, a baseball thrown at an angle of 60 degrees above the horizontal strikes a building 18 meters away at 0.8 meters above from which it is thrown. Ignore air resistance. Find the magnitude of the initial velocity of the baseball. Find the magnitude and the direction of the velocity of the baseball just before it strikes the building. Well, I'm glad they told me about to ignore air resistance, because I would have thrown that right in the formula right now and just screwed up the whole problem. Just kidding. Let's get started. Physics to get to my menu. These are all certain types of problems. For instance, anything you're dealing with trajectories or something thrown or tossed or dropped, whatever, it's always a path of an object in my menu. So you go to a path of object. And I always recommend that you circle what's asked for. Of course, this is the initial velocity of the baseball. And then on the side of your problem, put down what's given. In this case, theta is given, the angle, and the distance away from the object, and some height. So here we have theta, distance, and height. Here we're going to choose those variables. For initial velocity, we're asked to find initial velocity. One thing that always bugged me about physics was that, you see, this is always VO. This is used exclusively in the problems in books, and etc. And yet they say for initial velocity, find the initial velocity. Well, the O here was originally original velocity. Original velocity. That's the reason they use the O here. But now they screw it up by saying initial velocity and then use the VO term. I like to use VI term, but I changed them all to VO because to be more compatible with what's given out there. So anyways, you need initial height, downrange height, and distance downrange, and launch angle to find the initial velocity. And it's quite a... I'm ashamed of you that you just don't remember this right off the top of your head. So we're going to enter the variables. You have to press alpha before you enter anything into these entry lines here. So we're going to go alpha. The distance is 18 given. And it's in meters. I'm going to choose number 2. Initial height is alpha 0. It's off the ground. Okay. Alpha for the final height is, they give it as 8 meters. If an object is shot straight up, the angle would be 90 degrees if pushed off a cliff, or tailor would be 0. So keep that in mind when you enter angles. So in this case, they give you alpha 60 for the degrees. So I always show you what you've entered. You can check it and change it if it's not right. I say it's okay. The formula is derived from the RT formula, VO times cosine of theta times T for the I equals distance. Then solving for T and substituting T into the J, H plus, etc. You can look at this here and give you a little bit to, instead of me reading it off. But mark this on your paper. Few points on your test or homework, whatever. The downrange height is subtracted from the initial height to use in the formula. It's always done that. It's always, because a lot of times it appears underneath the square root sign. So, and of course, you can't have a negative under the square root sign. So, but irrespective of that, it's downward. Here's the formula. Write that on your paper. Do all the computations just like you would do it if you had your own calculator. And here's the answer. The original velocity is 16.52 meters per second. Now that we know velocity, and the angle, we can find almost everything about a path of an object. So the x component of velocity in every problem is VO times cosine of theta, 8.226 meters per second. And the y component is the original velocity times sine of theta. And that equals 14.31. They use that in all the formulas too. The time at the end of the distance downrange of 18 meters is the distance divided by the x component of velocity, equals 2.179 seconds. And everything is time in these problems because they're always at a certain time. That's the velocity or height or distance, etc. So you have to always find time. Now VFY equals the vertical velocity at this time, and that equals minus 7.07 meters per second equals Vy minus GT, G times T. So, and then Vx is the horizontal velocity. That's good for whatever time is in the problem. So you don't need a particular time, but the vertical you do. And so the Vf is equal to the final velocity as it hits the building, 10.87 meters per second. And the angle is the tangent of equals minus 56, or really 303.04 degrees. Keep in mind, these are always right triangles. For instance, when this is rise over run, so this is the tangent is you know, the y over the x, and in a right triangle. And this is the answer of 10 meters, 10.84 meters, which we just found up there, is the hypotenuse between having the x value on the bottom and then the y value, which was at a minus 707. Remember that? Going up that's the y value, and then the x was the 8.06. Well, you take, of course, you use the Pythagorean theorem, you know, a squared plus b squared equals c squared. So that's how they come up with the answer of the hypotenuse is the actual velocity. And the angle, you can see it coming down here at 3 and hitting the building at this angle. So pretty neat, huh? EveryStepPhysics.com. Subscribe to my videos to see more of them. Have a good one.